Section 1.2, describing distributions with numbers. Up until now, in section 1.1, we only talked about measuring center in terms of median. Obviously, everybody knows how to find a mean. You add up the total number, divide by how many there are. Okay, but there are times where you're going to want to describe center by mean, and there are times when you are going to want to describe it by median. Two most common measures of center that we're going to use, and this is what you will always refer to. So when you're asked to describe the center of a distribution now, you will always talk in terms of mean or median. Remember, mean is just the average. To find the mean, you add up the total number, or you add up the items in the data set, divide by the total number in the set. This abbreviation X bar always represents the sample mean. So we're talking about a sample value there, not a population value. The mean is sensitive to the influence of a few extreme observations. What do we call extreme observations, or observations that didn't fit the overall distribution? Those are potential outliers. The mean is very sensitive to outliers. Therefore, the mean is said to not be a resistant measure of center. Resistant meaning that the outliers don't affect it. Well, they do affect the mean. That's why it is not a resistant measure of center. Median is the second way. We've already talked about how to identify a median. We're going to get a little bit more specific now. Median, remember, is the middle value. The median M is the midpoint of a distribution. The number such that half the observations are smaller and the other half are larger. To find the median of a distribution, we arrange all the observations in order of size from smallest to largest. Now, it matters whether there is an even number or an odd number of observations. If the number of observations or data points is odd, then the median is the single middle number in the middle. If the number of observations n is even, then the median is the average of the two middle numbers. So in other words, if there's an odd number of data points, there always will be one single number in the middle. If there's an even number of data points, there are two numbers in the middle, and then the median would be the average of those two middle numbers. So let's look at a simplistic example here. If I have these 5 test scores, we have an odd number of test scores here. So there is a single middle number at 84. So the median of this data set would be equal to 84. Let's take another set of test scores, 74, 76, 83, 86, 90, and 92. Now in this data set, there are an even number of values, so there are two numbers in the middle right here. So now we need to find the average of those two values. Obviously for these, it's pretty easy to know that the number in between there is 84.5. But if those were some more difficult numbers that you couldn't do in your head, you simply find the average, and the median in this case is 84.5. So it matters whether there is an even number or an odd number of data points. So when do we use mean? When do we use median to describe center? The median is a resistant measure of center. Therefore, we will often use the median to describe the typical or center of the data set. What's the rule that we are going to follow? Well, we're going to use the mean to describe center anytime that we are working with a symmetric distribution. We're going to use the median to describe center anytime we are working with a skew distribution. So let's look at a third data set here. Again, imagine these are a set of 5 test scores. If we're asked to describe the center of this data set, we could easily find both the mean and the median of this data set. Mean, add them all up, divide by how many there are. 382 divided by 5, and we get a mean of 76.4. Median is the single middle number, 82. So the question is, which one of these values would we want to use to describe this distribution? Well, if we look at this distribution and we imagine doing a graph of this, what is the shape of this distribution going to be? Because of this value right here of 40, which you can see does not really fit the overall pattern there of those scores, that means that this distribution is going to be skew to the left. Since it is skew left, what measure of center do we want to use in a skew distribution? The median. And you can see here how you can use the numbers as well to determine the shape of the distribution or help us determine the shape. We can see the mean is much less than the median. And remember, the mean is always pulled in the direction of skewness. So if the median is at 82 and the mean is at 76.4, you can see the mean is being pulled to the left, meaning that we are more than likely working with a skew left distribution. Example 28. Survey of study habits and attitudes is a psychological test that evaluates college students' motivation, study habits, and attitude towards school. Private college gives the SSHA to a sample of 18 of its incoming first-year women students. Their scores are given there. Make a stem plot of the data. The overall shape of the distribution is irregular, as often happens when only a few observations are available. Are there any potential outliers? About where is the median? And what is the spread? So let's first make our stem and leaf plot here. We can see that all scores are above 100 and go up to 200. Remember, our stem has to be all the digits but the last one. So if we're going to do the scores exactly how they appear, that means our stems are going to be 10 through 20. Our leaf, remember, can only be one digit. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Our leaves then. Scores in the between 100 and 110 are 101, 103, 109. Scores in the 110s is just a 115. Scores in the 120s, 126, 126, 129, 137, 137, 140, 148, 152, 54, 154, 165, 165, 178. And the last one is way out here at 200. Okay, are there any potential outliers? Well, when we look at the shape of this distribution, we can see that we have a gap in the 180s, 190s, and then all of a sudden we have one value out at 200. So we do have a potential outlier. At a score of 200. One thing I should have done here, remember, for a stem plot, you always need a key. Our key in this case is going to be, again, you can pick whatever data value you want. That represents a score of 126. Median. Let's identify the median of this data set. There are 2, 4, 6, 8, 18 scores here. Even number of scores, which means there will be two middle numbers. So if I count in from the top, 1, 2, 3, 4, 5, 6, 7, 8, 9. From the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the two middle numbers. So 137. Oops, counted in the wrong way here. Should be 140. So 137 and 140 are our two middle scores. So our median is going to be the number in the middle of those. $138.5. Spread. Range of values, if you exclude that score of 200, the range is going to be 178 minus 101. which is 77, and make sure you note if we exclude the value of 200. Find the mean and median of the scores. Which is larger, y? Which is a better measure of center for this data set? Well, we already found the median. Median is equal to 138.5. Let's go ahead and find the mean. And to do this, let's go to the calculator. We want to go into our stat menu. We want to edit. Let's clear out list 1. Remember, we do that by hitting the clear button once L1 is highlighted. After you hit the clear button, you must hit the down arrow. That clears out the entire list. Let's put in these data points. And I missed one because I don't have 18. Let's check here, 137. 65. Must have missed one up here. Yep, I missed one of the 126s. It doesn't matter where you put that in, so I'm just going to go down here and put that at the end. Put in another 126 here. There's my 18 data points. Once you have that, go back into your stat menu and over to calculate, and we have one variable stats, which is going to give us a ton of information. So hit enter. It says it's going to do one variable stats. If you do not put in a specific list here, it will automatically draw from list 1. If you're not comfortable with that, select list 1. You can see your list if you look at your keypad for 1, 2, 3, 4, 5, 6. In blue above those values are L1, L2, L3, L4, L5, and L6. I want to select list 1, hit enter, and there's a bunch of information. Let's go through this menu. X bar. We just talked about X bar. X bar is the sample mean, so there's the mean of the data set, 141.056. Sum of the X's means that we are adding up all of the data points. That's the sum of them. That will be used in a standard deviation calculation later on. Sum of the data points squared, which will also be used in formulas. S of X is standard deviation of the sample. Sigma of X you will never use. Disregard that. Pretend your calculator doesn't even give you that value. It doesn't do you any good. N equals 18 tells how many data points. And then down here is the 5-number summary, which we're going to talk about in a second. The minimum value in our data set, quartile 1. The median, 138.5, which we already knew. Quartile 3, 154. And the maximum is 200. So one variable stats will give you all of that information by just hitting that one command underneath your calculate menu inside your stats menu. So X bar, which is what we needed, 141.056. Which is larger? Well, obviously the mean is larger. Why is the mean larger? The mean is larger because the distribution is skew right. And remember, in a skew distribution, the mean is pulled away from the median in the direction of skewness. So what is a better measure of center here? Well, because we're talking about a skew distribution, the median is the best measure of center. Looking at our next example, mean salary. Last year, a small accounting firm paid each of its 5 clerks $22,000. 2 junior accountants $50,000 each, and the firm's owner $270,000. What is the mean salary paid at this firm? How many of the employees earn less than the mean? What is the median salary? And write a sentence to describe how an unethical recruiter could use statistics to mislead prospective employees. Well, let's start with the first question. What is the mean salary of this firm? Okay, you need to be careful here because this is going to be not just straightforward where we add up the 3 salaries and divide, because we have 5 people earning $22,000, so we need the total money earned dividing by the number of people earning that dollar amount. 2 junior accountants that earn $50,000 and 1 owner that earns $270,000. So there's the total dollar amount earned divided by 8 employees. Plug that in to your calculator. We get 480,000 divided by 8, which means the average salary is $60,000. Median. So the second question was, how many earn less than the mean? 7 of the employees earn less than the $60,000. Median salary, if I lined all those up, we know the 2 middle numbers are going to be the 4th and 5th person. 4th and 5th person all falls in these first 5 if we lined up 22,000, 22,000, 22,000 5 times, 50,000, 50,000, 270. The median salary is going to be 22,000. And finally, write a sentence to describe how an unethical recruiter could use statistics to mislead prospective employees. Person could recruit employees to work for the company by telling them the average salary is $60,000 when in reality only one person in the firm makes at least that much money. Okay, measuring spread. Up until now, talking about spread, we have only used range. Range, remember, is a simple single data value, which is the largest minus the smallest. So the range is always a single number. The pth percentile is the value such that p% of observations fall at or below that value. Quartiles, remember when we looked at the calculator and we did one variable statistics? Down at the bottom gave us that 5-number summary. That 5-number summary is using these quartile values. First quartile is simply the 25th percentile. You will see that abbreviated as Q of 1. Second quartile is the 50th percentile, which is also known as the median. You will usually see that not given as Q of 2, but usually as just M for median. Our third quartile is the 75th percentile, and you will see that abbreviated as Q of 3. Now, when we identify the quartiles, it is all based on identifying the median first. You know how to identify the median. Quartile 1 then, once you identify the median, you've split the data in half. You have a first half of the data from the smallest up to the median. You have a second half of data from median out to the largest value. The first quartile becomes then the median of just the first half of the data. The third quartile becomes the median of the second half of the data. So identify the median first. Once you have that first half of the data, find the median of the first half. There's your first quartile. Do the same thing for the second half of the data, and there is your third quartile. So our 5-number summary is the set of observations consisting of the smallest observation, first quartile, median, third quartile, and largest observation, written in order from smallest to largest. In symbols, the 5-number summary is given by our minimum value, quartile 1, median, quartile 3, maximum. Then when we do a box plot, there would be a box plot, and the box plot is just a graphical representation really of the 5-number summary. This would be our minimum value here. The beginning of the box is our first quartile. The line in the box is our median. Line at the end of the box is our third quartile, and this value out here would be our maximum point. So a box plot is simply a graph of the 5-number summary. The central box spans the quartiles Q1 and Q3, as you can see from our diagram here. A line in the box marks the median, and lines extend from the box out to the smallest and largest observations. That is a standard box plot. The type of box plot that we will be using most of the time is called a modified box plot. In a modified box plot, and this will make more sense when we actually look at one, but a modified box plot plots outliers, which are those points more than 1.5 times the interquartile range, above quartile 3 and below quartile 1, and it takes those outlier points and graphs them as single points. The lines then extending from the box stop at the smallest and largest data points not flagged by the 1.5 times the interquartile range value. So now we have a numeric test that'll help us determine whether points indeed we should consider them outliers or not. We're going to take 1.5 times the interquartile range. We're going to add that to quartile 3. We're going to subtract that value from quartile 1. Any data points that fall outside those new values, then we are going to call outliers. So now let's look a little more closely at how we are going to determine outliers. The interquartile range, IQR, is the distance between the first and third quartiles. Interquartile range then is going to be quartile 3 minus quartile 1. We're going to call an observation, and notice the language that's used here, a suspected outlier if it falls more than 1.5 times the interquartile range above the third quartile or below the first quartile. So in a modified box plot, we still have a box. We still have the median marked inside the box. We're still going to have lines coming out from both sides of the box. But what we may have in addition to that, so again, remember the parts that we know here. Quartile 1, the median, quartile 3 does not change. Now, the ends of those lines may no longer be the minimum and maximum points, because in a modified box plot, that minimum point, as well as some points out here, or you could have multiple points on either side, But again, these points that are graphed individually are the potential outliers. In other words, those are points that are more than 1.5 times the interquartile range above the third quartile or below the third quartile. Looking at some computer output here. Figure 1.2 displays computer output for data on the amount spent by grocery shoppers in exercise 1.6. So it's the data set that we looked at in section 1.1. We have two different types of computer output. We have data desk and Minitab. Again, you will have to be able to read computer output on quizzes, tests, and the AP exam. Let's look at data desk first. It says it's a summary of spending here. Count. Count is the number of data points. We have the mean, the median, the standard deviation, the minimum value, the maximum value, the lower percentile. What do you think lower percentile means? Well, that's the first quartile. Upperth percentile is the third quartile, so we can see both of those. Minitab does a little bit better job of describing variables. We have 50 items. We have a mean of 34.7, a median of 27.85. Trimmed mean, you will not use. Trim mean takes off, I believe, the smallest and lowest, or smallest and highest value of the data set, and then calculates the mean on without those included. You will never use the trim mean. Standard deviation is 21.7. Standard error of the mean, which we will talk about later on, is given there. And then here's your parts of your 5-number summary along with the mean. That would be your 5-number summary. So if we want to identify potential outliers here, remember first of all our interquartile range, 1.5 times the interquartile range, which remember is the third quartile minus the first quartile. So I would take 1.5 times, take 45.72 minus 19.06. We get 26.66, or 39.99 is 1.5 times the interquartile range. So now when I want to decide whether we have outliers or not in this data set, what we would do is take the first quartile, subtract off 1.5 times that interquartile range. When we do that, we take 19.06 minus 39.99, we get negative 20.93. Were there any negative amounts of money spent at this grocery store? No, the smallest one was $3.11. Obviously, nobody spent a negative amount of money unless if you are somebody that uses a lot of coupons and had a bunch of free items. It's pretty much impossible to have a negative dollar amount at a grocery store. On the upper end, we need to take quartile 3 plus 1.5 times the interquartile range. So I'm going to take 45.72 plus 39.99, and we get $85.71. Now, any values greater than $85.71 in this data set tell us that those are going to be suspected outliers. Well, we know our maximum value in the data set was $93.34, so we know that we have at least one potential outlier. We need to look specifically at the data set on page 48 to decide whether we have more than just that one outlier. If we did not have the entire data set, our first question here, find the total amount spent by the shoppers. If we only had these summary statistics given to us here in Minitab, how could we find the total amount of money spent by the shoppers? Well, we know the average amount spent by each one is $34.70, and we know 50 shoppers spent that average amount. So if I want to find the overall mean, I could take 50 times 34.7, not the overall mean, but the overall dollar amount spent, which means they spent a total of $1,735 approximately. Make a box plot, and I'm going to add a word in there. to make a modified box plot from the computer output, check for outliers. Okay, well, in order to make our box plot, we need the minimum value, which is $3.11. We need quartile 1, which was 19.06. Median, which was 27.85. Quartile 3, which is 45.72. Maximum, 93.34. And we have outliers. And the only way I know all of the outliers is to go to page 48 in your book and look at the original data set. When we do that, we're looking for values that are bigger than this $85.71. When we look at that data set, we see there were $3 amounts bigger than that. 85.76, 86.37, and 93.34. From here, we need to put our scale. Well, the most spent was $93.34. The least spent was $3.11. So basically, we need a scale that goes from 0 to 100. Let's put that scale on our line. Okay, there's our scale, and now we need to do our actual box and whisker plot. Minimum value, $3.11, so we're going to put a dot there at the minimum value. Quartile 1, $19. Put a line there for the beginning of our box. Median, $27.85. Put a line there. Quartile 3, $45.72. Put a line there. Let's make our box. Let's connect our line to that box. And now we need the biggest point that is not an outlier. So we're looking for the data value right before 85.76. And that is where we are going to put our dot to end our box plot. Then outliers are graphed as single points. So I have a single point at 85.76. I have a single point at 86.37. And I have a single point at 93.34. There's our modified box plot. From our box plot, again, a lot of information we can be told from the box plot. We know where quartile 1, median, and quartile 3 are, so we could find the interquartile range very easily. Remember, the quartiles break it up into quarters, so we know 50% of our data is included inside the box, with 25% being in here, 25% being in here, 25% of the data here, and 25% of the data out here to the end of that outlier. Next way we have of talking about spread is by standard deviation. The variance S squared of a set of observations is the average of the squares of the deviations of the observations from their mean. In symbols, the variance N of N observations is given by this. So notice what's happening is we're taking each data point, x1, x2, x3, x4, all the way up through the last or x of N term. We're subtracting the mean from it, and we are squaring that value. Then we are dividing by n minus 1. So what we're doing is exactly what it is told up here. We're finding the average of the squares of the deviations from the mean. More compactly, we can give the variance, which is given as s squared, as the sum of all the data points minus the mean squared divided by n minus 1. The standard deviation then is the square root of the variance. So anytime we know variance, we can find standard deviation. Anytime we know standard deviation, we can square it and find the variance. Standard deviation then just becomes the square root of that, Obviously, if you had to calculate standard deviation by hand all the time, it's going to be a long calculation. You will not. You have your calculator that you can use on everything. Standard deviation is another way of measuring spread by looking at how far the observations are from the mean. The degrees of freedom is n minus 1 because that is the number of data values that can vary freely. Degrees of freedom is something that's going to come up a lot in a lot of test statistics that we use as well. Okay, this idea of degrees of freedom is the number of data points in a data set that can vary freely before we have to have one that has to be a certain value. The easiest way to think of that is if you think of finding an average. Let's say you know you have to have an average test score of 88 in order to get an A in this class. Let's say your first test scores were 88, 89, and 90. And now, on this last test, there is a value that you have to receive in order to average an 88. Those first three tests, you really could have gotten anything, unless if you bombed the tests, obviously. Okay, but those first three tests can vary freely. That's the idea of degrees of freedom. It's this fourth test now that you must get a specific score on in order to get whatever average it is you are looking for. Some properties of standard deviation. S, which again is standard deviation of the sample, measures spread about the mean and should be used only when the mean is chosen as the measure of center. Well, if we're only going to talk about standard deviation when the mean is chosen as the measure of center, that means that we're only going to use standard deviation if we are talking about a symmetric distribution. So for symmetric distributions, we are going to talk in terms of mean and standard deviation. If it is a skew distribution, we are going to talk in terms of median and interquartile range. Standard deviation is 0 only when there is no spread or variability in the data set. This happens only when all observations have the same value. Otherwise, the standard deviation will always be greater than 0. As the observations become more spread out about their mean, the standard deviation gets larger. Standard deviation, like mean, is not resistance, which means a few outliers can make the standard deviation very large. 5-number summary is usually better than mean and standard deviation for describing a skew distribution or a distribution with strong outliers. Use X bar and S only for reasonably symmetric distributions that are free of outliers. So again, recapping, the shape of the distribution is going to tell us which numeric summary to use. For skew distributions, we will use the 5-number summary, which is median based. Again, you will talk in terms of median and interquartile range for center and spread. For symmetric distributions, you will use the mean and standard deviation. So now it's all laid out to you anytime you are asked to describe a distribution. Identify the shape first. If it is symmetric, then you're going to talk about the center in terms of mean and the spread in terms of standard deviation. If the shape of the distribution is skew, then you are going to talk about the center in terms of median and the spread in terms of interquartile range. Looking at the next example here, problem 40, which measure of center and spread should be used for the following data sets? In each case, write a sentence or two explaining your reasoning. The Treasury bill returns in figure 1.22 on page 88. So in your book, look at page 88, which is going to be this stem plot here on the right for Treasury bills. We can clearly see that we probably have one outlier value here at the bottom of our graph, so towards the bigger values. Other than that, if that wasn't there, we could probably say this is fairly symmetric, although These lower treasury bills here, there seem to be quite a bit more than the upper ones, so I think it's pretty clear that this distribution is probably skewed to the right. So which measure of center and spread would we use? We should be using the median and interquartile range. Because the distribution is skew right. Letter B, the 60 IQ scores of 5th grade students on page 49. So again, if you go to your book and go to page 49, we look at these IQ scores here. There's a histogram of the IQ scores. That's really about as symmetric as you're going to get with a real data set. So we can say that this distribution is relatively symmetric. Since it is relatively symmetric, we are going to use the mean and standard deviation to describe center and spread. Notice when you use symmetric, you're never going to want to say that it is symmetric because, again, very rarely it is exactly symmetric. So use soft words like fairly symmetric or relatively symmetric or whatever it is you may choose. 42. Create a set of 5 positive numbers. Repeats are allowed that have a median of 10 and a mean of 7. What thought process did you use to create your numbers? So I'm going to line up 5 numbers. We have to have a median of 10. Well, since we have an odd number of points, that means our middle number here has got to be 10. That's going to guarantee us that the median of this data set is 10. Well, in order to find the mean of the data set, we know we're going to add them all up and divide by how many there are. So we're going to divide by 5. And if we're going to have a mean of exactly 7, we know the total has to be 35. That's going to give us a mean of 7. So now if our total has to be 35, and this value here is 10, that means then that the other 4 numbers must add up to 25. So pick the numbers however you want. Remember, you can use repeats. Well, since this median is already 10, we don't want to take up too many more numbers in these last 2. Otherwise, it's going to be impossible since we have to have 5 positive numbers in order to add up only to 35. So let's leave these at 10. Now we have a total of 30, which means our last 2 numbers then have to add up to 5. So it could be 1 and 4, could be 2 and 3. Again, there isn't necessarily a right or wrong answer as long as the conditions of the median being 10 and the mean being 7 are satisfied. Okay, changing the unit of measurement. A linear transformation changes the original value x into the new variable x new given by the equation in this form. X of new is a plus bx. Adding a constant a shifts all the values of x upward or downward by the same amount. And we know from what we know about linear functions that this is really just the y-intercept. Notice this is in the form, or what we're used to seeing is y equals mx plus b. In statistics, for whatever reason, they don't write it as y equals mx plus b. They write it as y equals B plus mx. I don't know why, probably just to be different from mathematicians, but it's the same thing. So now B is going to be our y-intercept, mx is our slope. Multiplying the positive constant B, so multiplying the positive constant B, which we better know as slope, so multiplying by that changes the size of the unit of measurement. So the effects of a linear transformation on measures of center and spread apply to these rules. Multiplying each observation by a positive number B multiplies both the measures of center, the mean and the median, and the measures of spread, the interquartile range and standard deviations, by B. So when we change the slope, let's say we multiply it by 3, then we need to multiply the mean, the median, the interquartile range, and the standard deviation all by 3 as well. Adding the same number, A, so changing the y-intercept to each observation, adds A to the measures of center and to the quartiles, but does not change the measures of spread. Also, a linear transformation does not change the shape of the distribution. So the shape of a distribution, we can do anything we want to the data points as far as linearly transforming it, but it will not change the shape of the distribution. If we multiply by a slope, that's going to change both measure of center and spread. If we add the same number, it's going to change the measures of center, but does not change the measures of spread. Okay, this is just kind of a recap of some of the stuff we've talked about. To answer a statistical question of interest involving one or more data sets, proceed as follows. Data, organize and examine the data. Answer the key questions from the preliminary chapter: who, what, where, when, how, and by whom. Construct appropriate graphical displays. We now have numerical displays, 5-number summary, mean, standard deviation. And then interpret. Again, when you interpret, always in the context of the problem. Problem 46. Suppose that teachers in the previous exercise, so we'd be looking at problem 45, receive a 5% raise. The amount of the raise will vary from $1,500 to $3,000 depending on the present salary. Will a 5% across-the-board raise increase the spread of the distribution as measured by the distance between the quartiles? Do you think it will increase the standard deviation? Okay, so if we're making a 5% raise, okay, what we need to ask is, are we adding the same dollar amount to everybody's salary? Or is it a different dollar amount depending? Well, this is a different dollar amount. So that means we are multiplying by 0.05. That would be a slope. So a 5% across the board raise will increase both the median and mean, as well as changing the measures of spread, both the standard deviation and interquartile range. And the reason I know that is from what we were told right here. Multiplying each observation by a positive number, in this case 0.05, multiplies both measures of center and measures of spread by that value. Problem 50. Each of the following settings give the values of A and B for the linear transformation that expresses the change in measurement units. To explain how the transformation will affect the mean, the interquartile range, the median, and the standard deviation of the original distribution. You collect data on the power of car engines, measured in horsepower. Your teacher requires you to convert the power to watts. 1 horsepower is 746 watts. So we want to change here. X of new, which is going to be our new variable in terms of watts, is going to be 746 times each of those horsepower measurements. So what is going to happen here? Well, we are multiplying. That is a slope. So that is going to change everything. It's going to change the mean, the interquartile range, the median, and the standard deviation. So the mean, median, interquartile range, and standard deviation will be affected. Letter B. You measure the temperature in degrees Fahrenheit of your school's swimming pool at 20 different locations within the pool. Your swim coach wants the summary statistics in degrees Celsius. So we have that formula for converting from Celsius to degrees Fahrenheit. Let's solve that for C. The first thing I need to do is subtract the 32 over. Multiply by 5/9. Our final equation is going to be C equals 5/9 F minus 160 over 9. So putting it in the form that we were asked, our X of new, so our transform variable is going to be 5/9 times degrees Fahrenheit minus 160 over N. So now changing this constant, what does that do? Well, when I add or subtract, that adds or subtracts from only the mean or the median. Does not affect our measure of spread, but multiplying by this 5/9 is going to affect everything. So the mean and median will be multiplied by 5/9 and reduced by 160 over 9. The interquartile range and standard deviation will simply be multiplied by 5/9. And actually, if I go back to the last one we just talked about, I could be more specific here and say the mean, median, interquartile range, and standard deviation will be, and what exactly will be done? Well, will be multiplied by 746. Letter C. Mrs. Suanos has given a very difficult statistics test and is thinking about curving the grades. She decides to add 10 points to each of the students' grades. So their new score is going to be their old score plus 10. So this time we are not changing slope. We are simply adding 10 to each of their scores. When we add or subtract a number from all of the data points, remember that only affects the mean and the median. So the mean and the median will be increased by 10 points. The interquartile range and standard deviation will not be affected. Last two slides here are just a summary of the chapter. Again, I encourage you to read through this on your own. If there are certain things in here that you are not sure of, make sure you know the bold-faced words and what they mean. Those are the vocabulary that's going to be important to your success in this chapter. If there's conceptual things you do not understand, I suggest that you come in the morning and see me to get some extra help, or make sure you are asking some questions during class time to increase your understanding of the topics.